So today we'll discuss about the electronic structure, the structure of an atom. So in IGCSE, what you have studied the structure of an atom in terms of shells. So, and we did for three shells, first three shells. The nucleus is having neutrons and protons inside, which we call nucleon. Then we discussed the first shell can have maximum 2. The second shell can have maximum 8, and then so on. That is what we have discussed in IGCSE O levels. But now what you will learn the structure of an atom in detail. So what is the structure of an atom in detail? Here you will learn a new concept. You will learn about the concept of subshells. So basically what we have atom. Atom is having shells. Maximum it can have 7, and then these 7 shells are further divided into subshells which are known as S, P, D and F. And these subshells have orbitals. Orbital means which can have maximum only 2 electrons in opposite spin. So if you want to understand the concept, like if you have a building, so example of the building, the whole building is atom. Then building will have floors, levels, like 1, 2, 3, 4, 5, 6, and there will be the 7th as well. So these floors, what these floors are representing, each floor is representing a shell, and each floor will have apartments. So what these apartments are representing, subshell, and inside each apartment there are rooms. And what these rooms are representing, orbitals. Is it clear, the idea, the concept, that whole atom is like a building. A building is having floor, which is example of shell. Then each floor will have apartment, that is the subshell. And then these subshells have orbital, which we call that as a room. And about the subshell, the S subshell maximum can hold 2 electrons. P subshell can maximum hold 6 electrons. D subshell can maximum hold 10 electrons. F subshell can maximum hold 14 electrons. And each subshell, like S subshell, which can maximum hold 2 electrons, so it is having only one orbital or one room. P subshell can maximum hold 6 electrons. So how many orbitals will be there? There will be 3 orbitals. Because each orbital maximum can hold 2 electrons. So there will be 3 orbitals present in P. D maximum can hold 10 electrons. So how many orbitals it can have? Because each orbital can hold 2 electrons. So that is 5 orbitals. And F maximum can have 14 electrons. So how many orbitals will be there? It will have 7 orbitals. So S will have only one orbital, and how we represent the orbital? We represent it by a box. P will have 3 orbital. So how we represent 3 orbital? We represent it by 3 boxes. D will have 5 orbitals. So it can have 5 boxes, and F can have 7 orbitals. 1, 2, 3, 4, 5, 6, 7. So I made it 8, so it should be 7. So there are 7. And how the electrons are arranged in each orbital, like S can have maximum 2 electron, maximum number. So one will be clockwise, another one will be anti-clockwise. P can have maximum 6 electrons. First they will occupy singly 1, 2, 3, 4, 5, 6. This is how we complete. D can have maximum 10 electrons. 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. And F maximum can have 14. So first they will occupy singly 1, 2, 3, 4, 5, 6, and 7. Then 8, 9, 10, 11, 12, 13, and 14. So this is how the electrons are arranged in these orbitals. Is it clear? The idea, the concept of the shells. So we have 7 shells. Then these shells have subshells, which is SPDF, and these subshells have orbitals which can hold up to 2 electrons in opposite spin. So how to write an electronic configuration? So for writing an electronic configuration, you have to learn this idea. In which manner you will learn? You will learn in this manner. Look, 1s, the first shell, shell number 1, is having only one orbital, one shell, one subshell, which is S subshell. Then shell 2, it is having 2 orbital S and P. So this will be 2s. 2 is representing that this S belongs to the second shell, and 2p means that this p orbital belongs to second shell. Then shell 3 is having S, P and D, but how we can distinguish? So it will be 3s, 3p and 3d. Then shell 4, 4s, 4p, 4d and 4f. So how to learn this all? Otherwise you will be confused. So there is a simple way to memorize this. First what we do, we will increase one shell. Like first we write 1s, shell 1. Then for shell 2, we'll write 2s and 2p. Then for shell 3, we'll write 3s, 3p, 3d. So what we are doing, we are increasing one subshell. Then the fourth one, 4s, 4p, 4d and 4f. And for fifth one, so we increase one, now we start to decrease them. So 5s, 5p and 5d. Then the sixth shell, 6s, 6p. And the seventh shell, it will be 7s. Is it clear? Just the idea to learn this arrangement and how the electrons will fill up. What is the order of filling up? So electron first will go to 1s, then it will go to 2s, then from 2s it will go to 2p, and from 2p it will go to 3s. Then from 3s to 3p, and then it will go to 4s. So how to learn these zigzag lines? So it's also a simple way. So we draw the diagonal. So this is how we complete the filling of the electron. So electron will always first go to 1s, then it will go to 2p, then from 2s, then from 2s it will 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. So how to complete the structure, how to write electronic configuration? So if I say I want to write the electronic configuration for calcium, Ca, which is 20 and 40 or 40 and 20. So I have to arrange 20 electrons. Okay. So how to write the electronic configuration of calcium? So first I will write 1s. How many electrons? S can have maximum, S can have 2. So the number of electron which it can have, we'll write like it is having 2 electrons. So 1s, 2. Then after 1s, it will be 2s. Then how many electrons will be there? In 2s, maximum, because in S, maximum can have 2, P maximum 6, D maximum 10, and F maximum 14. So there is a difference of 4, 4. Then from 2s, it will go to 2p. And how many? It can have maximum 6. So right now we have arranged 10 electrons. From 2p, it will go to 3s. And 3s maximum can have 2. So we arrange 12 electrons. From 3s, it will be 3p. So we'll write 6. So we now arrange 18 electrons. From 3p, it will not go to 3d, it will go to 4s, because electron always occupy the orbital with low energy. So 3s is having low energy, that's why it will go to 4s is having low energy, that's why it will go to 4s. So it will be 4s2. So this is the electronic configuration of calcium: 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So we arrange 20 electrons. Is it clear, the example of calcium? Then another example, like we want to arrange chlorine, which is 17 and 35.5. So we have to arrange 17 electrons. How to arrange 17 electrons? So it will be 1s2, then 2s2, then 2p6, then 3s2. So right now we arrange 12 electrons. Then 3p, P maximum can have 6, but we don't have left with 6 electron. We are only left with 5 electron. So we'll write 3p5. Maximum it can have 6, but because we are left with only 5 electron, that's why we are writing 3p5. So this is the electronic configuration of chlorine atom. If we want to show in electron in a box model in terms of orbital, so S is having one box, 2s will also have one box, because it is P, so P will have 3 boxes. 3s will have one box because it is S, and again 3p will have 3 boxes. So how the electrons is arranged in terms of orbital? This is 1s, 2s, 2p, 3s, 3p. So 2 electrons are there, 1, 2. This is 2, 1, 2. This is having 6 electrons, so 1, 2, 3, 4, 5, 6. First make them in the same direction and then or opposite spin. It's having 2, so 1, 2. This is having 5, 1, 2, 3, 4, 5. So this is how electron we represent in terms of orbital for this chlorine atom. Is it clear, this example of chlorine? So it is very important that you learn this pattern which I drew, so that you will not make any mistake in the exam. Then another example, like if we have iron, which is 26, the atomic number. So we have to arrange 26 electrons total. So first it will be 1s, 2, then it will be 2s, 2, then it will be 2p6, so we arrange 10, then it will be 3s2, so we arrange 12, then it will be 3p6, so we arrange 18, then it will be 4s2, so we arrange 20, then it will be 3d, maximum it can have 10, but we are left only with 6, so we'll write 3d6. So this is for an iron atom. And to represent electron in a box, so S will have a single box, P will have 3 boxes, again S will have single box, P will have 3 boxes, and D will have 5 boxes. So when we arrange the electron, this is having 2 electrons, so 1, 1, 2. This is having 2, 1, 2. 1, 2, 3, 4, 5, 6. Then 1, 2, 1, 2, 3, 4, 5, 6. Then 1, 2, and this is having 6, so 1, 2, 3, 4, 5, and then 6. So this is how electrons are arranged in the orbital. Is it clear? The electronic configuration of an atom. So as a practice, you have to write the electronic configuration for from 1 to 30. So write the electronic configuration and show the orbital structure as well. So as a practice, from 1 to 30, you have to write the electronic configuration and show the orbital as well, and send it tomorrow before the session so I can discuss topic related to this electronic configuration tomorrow. Any question or a doubt related to the class today? So it is important that you draw this table to work out the electronic configuration. So I'll end the session and share this.